Welcome to another Nucida training session. Today, I would like to talk about timetables and time distance lines. How are the turnaround times of a train line measured? For this purpose, one needs the so-called minimum turnaround time. It is derived from travel time, which I would like to explain using the following animation. If you like, please give this video a thumbs up. Subscribe this channel and click on the bell to never forget our upcoming sessions. In terms of any questions, please leave a comment. We see a schematic track plan with its animation that represents train movements through time-distance lines. This is called a visual timetable. A timetable can be divided into many different components. We start with the smallest still meaningful timetable element, which is the section, i.e., the stretch of track that a train covers between two operating points, such as stops, passing points, junctions, etc. Like any other timetable component, a section can take on both a temporal and a spatial unit. Furthermore, sections do not have to be defined between two traffic or operating behaviors. Section boundaries can also be specific chosen track points where trains have a certain passing time. The travel time of such a section is determined today using tables with simulation programs, test runs, empirical data, or a combination of all these methods. Crucial to this is the so-called driving schedule or operating program. It is a compilation of acceleration sections, steady-state sections, coasting sections, and deceleration sections. Several such sections strung together should result in the train's route. Locally, this is correct, but not temporally, because the dwell times are still missing. Together with the dwell times, a train's journey time can then be defined. The train journey is, therefore, a concatenation of several sections of travel and stopping operations. It extends from the starting station to the terminus. The train journey has a one-to-one relationship with the train journey number. This means that each train journey within a day of operation has a unique number, and each train journey number must be assigned to a unique train journey. In the field of transportation companies, the terminology regarding train journeys and sections is very versatile. Sections are sometimes called travel distance, segments, train journey parts, operating program, or other names. In many transportation companies, the train journey number is colloquially referred to as the train number. However, this term is also used in many other areas, such as vehicle pool management or schedule planning, and often causes confusion. When trains are coupled or in concepts involving through cars, at least one of the two train parts receives a different train journey number. If the travel direction changes during a line trip, for example, at terminal stations, the journey before and after the change in direction still has the same train journey number. Therefore, such trains retain their train journey number when they are rerouted. Many technical processes depend on the train journey number, such as train tracking through the train number reporting system, passenger information, or train turn-back. In organized line operations, such as underground or tram systems, there is a combination of numbers consisting of a line number, route number, and control digit instead of a train journey number. The next higher-level element in the timetable hierarchy is the cycle. A cycle typically consists of two train journeys and two reversal operations. Exceptions include loop lines or triangle routes. A cycle is usually considered complete when a train returns to the exact location where it began its cycle. During this process, the train covers a specific distance, often measured in kilometers, which is a relevant factor for maintenance. However, the time component of the cycle, known as the minimum cycle time, is far more significant. Many economic and operational aspects depend on it, including the number of trains on a line, the schedule, and timetable efficiency. The calculated cycle time could, for instance, be 90 minutes when divided by the interval time, resulting in 3 trains needed for that line, each running at 30-minute intervals. In scheduled service, the cycle time is typically a multiple of an interval. But what happens when the calculated minimum cycle time, based on the train journey time and the calculated minimum turnaround time, doesn't align with a whole number? This is the norm. In one of our example lines, this is the case. 41 minutes of train journey time and 5 minutes of minimum turnaround time result in a minimum cycle time of 82 minutes. In such cases, additional buffer times must be added to the turnaround times until a whole number multiple is achieved. Therefore, turnaround times consist of an operational minimum turnaround time and the turnaround point travel times. Alternatively, though less commonly, these remaining time segments can be incorporated into the timetable travel times and dwell times. The topic of cycles becomes more complex in freight transport, especially in container transport and single wagon traffic. Since freight trains are regularly reconfigured, a cycle can be associated with a wagon or a group of wagons. It could even refer to the locomotive or a specific shipment on a freight train. In freight transport, you often encounter the term wagon cycle. In general, there is a cycle for a loaded train, known as a loaded cycle, and often a cycle in the direction of an empty train, called an empty cycle. However, in freight transport, things are not as straightforward as in passenger transport. Empty wagons are typically coupled with loaded wagons in a train for efficiency reasons. Moreover, it should be noted that wagon cycles in freight transport often differ significantly from those in passenger transport. They typically do not consist of two cycle runs, i.e., a round trip from one end station to the other and back. Instead, they comprise various performance runs, and a wagon often arrives at the same location only after completing multiple different performance programs. Its cycle can last for several days, weeks, or even months, and in some cases, the cycles are not pre-planned but are called up at short notice. On the other hand, freight train locomotives often have a regular schedule like passenger trains. In timetable engineering, you frequently hear the term train pair. This refers to two train journeys, one in the forward direction and a complementary one in the opposite direction. For example, when it's mentioned that there are 19 train pairs operating on a route each day, it means there are 19 trips, typically running at hourly intervals in each direction. Cycles, insertions, trips from the storage facility to the line, pull-ins, trips from the line to the storage facility, individual train journeys, empty runs, and special runs together, when properly combined, populate the network of the visual timetable. The visual timetable represents the operational program of a route. Let's take a brief look at the overall process of constructing a timetable. Everything we see here is just a specific part of a comprehensive process. I refer to it as the operational part of the timetable. Preceding this process is the service plan. In regional and local transportation, this is often the responsibility of authorities, transportation consortia, or other institutions. In long-distance and freight transportation, it is usually the responsibility of the transportation operators themselves. The service timetable, including its train journeys, is created based on this information. Subsequently, insertion trips, individual trips, empty runs, and special trips are added to the operational timetable. A cycle plan is then created from the operational timetable. It is only through this cycle plan that specific vehicles can be assigned to the offered transportation services. In parallel with the cycle plan, work schedules are designed for the personnel. Work schedule planning is further divided into shift planning, shifts, follow-up planning, service assignment, and other planning processes. Additionally, there are other planning processes, such as station occupancy planning and workshop planning, which have varying degrees of influence on all these planning steps. What makes all these planning processes challenging is that this hierarchical planning structure is not always a one-way street from top to bottom. Often, they go through an iterative process because each level influences the adjacent level, including higher levels. This is why timetables are often perceived as rigid and subject to change only once a year, typically with about a year of preparation. Train journeys are formed from multiple sections, and from there, cycles are created. The resulting times determine the number of trains and the operational program. Hopefully you find this video helpful. If you like, please give this video a thumbs up. Subscribe this channel and click on the bell to never forget our upcoming sessions. In terms of any questions, please leave a comment and see you next time.